is the average of a sample and the percentage of a sample are two of those unbiased estimators. Remember those two things we looked at earlier? Philip said flathead. The mode is not. The median is not. We can't do inference on the mode. We can't do inference on the median. We have to throw those out. So the average is here. Yay! But the problem is, look what the question asks you to do. What is the probability that we get heads on a coin spin? Not the average number of heads per 10. What's the probability of getting heads? We're not asking for an average, are we? We're asking for a percentage. Now, I know I kind of goofed around and made it a percentage by dividing 4.7 by 10, but we can do better than that. We're going to figure out first, and I think I can get this from this screen. Let me bump up here. Oops. We got, right there, 160 heads in total. We got 160 heads in total. What that guy right there is telling us, it's basically doing 0 times 0 plus 1 times 0 plus 2 times 3 all the way down, blah, 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 blah. So it's taking all of our data and saying this times this plus this. Remember weighted means back in 243? The first step you had to do was that times that plus that times that plus that times that. That's what this little guy right here is showing you, 160. So we got, sneeze. Maybe I don't. We got, does that work?
It does for me.
We got, well, good.
It's like 50%.
That's something we should test later. Yes, Frank.
So, shouldn't we have like the number of, is there somewhere in there that we actually have the number?
We have that too.
We already have it in
Oh,
there?
it was there. I didn't mention it yet.
Oh, okay.
We flipped 160 heads total. So what I'm doing here is I'm trying to smooth any goofy sampling error that might, is that okay? Is that not okay? Light? Okay, so you don't want to deal with the light on. That's right, I remember that. Light off, light on. You guys call it. Off. Thank you, Austin. There are 160 heads spun in total.
Okay.
According to the TI, 34 people in the room spun coins, which means we have 340 total coin spins. Yes? 340 total coin spins. $340 total coin spins. Yes.
That's what I was missing.
That's a little less than half, right?
Right, yeah.
So if it was exactly half, it'd be 170 out of 340. That'd be exactly 0.5. But do you have to get exactly 0.5 to believe that it's 0.5? Frankie, what did you spin on yours? You 4 and
6 and
6 and 4, 6 heads. And remember what she said? I got pretty close to 50-50. So 6 and 4 didn't make Frankie go like something's up. How about 3 and 7? Maybe mine's like, yeah, I think something was up then. Maybe 2 and 8. I know Melody did. She's like, what the hell? My coin's broken. Who got the 9 and 1? There was one of those, wasn't there? Am I imagining that?
No, there
There was one. Who got the 1 head?
No, there was 8.
They've already left.
So 1.
Oh, okay, 8 and 2. So we get 8
It was
heads and
8,
2 heads.
yeah.
And I'm sure 8 and 2 and 2 and 8 would be equally kind of like, what the
Yeah.
hell's going on? If I got 5 and 5, it's like, eh, whatever, it's a coin flip. But so the question again is, how close is close enough? Well, the first measure that statisticians are going to use to answer that is, they're going to use these two numbers right here and do what with them? They're going to divide them, because what's that going to give you? It's going to give you a percentage. It's exactly right, Nick. You're going to take these guys, and you're going to form what's called p hat, which is called your sample proportion, or your sample percentage, or your sample probability. This is going to be, let's use a color here. Might as well, we've got a bunch of them. P hat, AKA your sample proportion.
But don't we already have that from the average?
Well, we have a version of it,
Right.
don't we?
Yeah.
I mean, essentially we do. But the thing is that what the path I led you down over here, Austin, is not a path we would usually take. So in general, you're not going to have that. You're going to have this and this. You're going to have to derive it from right there. So what is 160 over 340? There you go. So Austin's point was, we already have that over here if we do 4.7 divided by 10. Yes, but in general, we're not going to start with this attack. It's just, this was the attack I wanted to start with because you guys were kind of going that route by talking about your individual sets of 10, like 8 and 2, 4 and 6. I wanted to make sure we attacked your questions first. So, that becomes 0.47. Exactly 0.47?
Oh, 5.
Oh, 5? Close enough. 0.47 is fine. We'll leave the decimals in there for calculation purposes. So we have an answer, don't we? We have an answer. Well, the same thing as the average, but again, we probably wouldn't do this in general. We say that the probability of spinning heads is 47%. How confident are you in that answer? I'm not talking about statistical confidence yet. Soon. How can if you? He's 95% confident. Holy. Wow. Well.
Well, the standard deviation still makes me question.
Why? Right. Say that nice and loud, Veronica. Please, one more time.
The standard deviation still
What's
makes
standard
me question. What we calculated.
Oh, but remember. Okay, good. Let's make this a little bit easier for everybody. All this stuff we did over here, we can't use that anymore.
Okay.
Because that was the average number of heads per 10 spins. We're losing all of that individuality and putting it in one big pot. And that big pot is 160 heads out of 340. No, I love what you're saying, but I'm questioning it too. Because Austin, the reason I'm making a big deal about your 95% confidence is, if I told you all to take your pennies again and spin them all again and keep track of the heads, would you get 47% again?
Probably not.
Probably not. Close to it, but probably not. And then if we did it another 340 times, would you get close to 47% and whatever you got the second time?
Yeah.
Would you get exactly that?
No.
Should we call that 95% confidence? I don't know. Alan, you're thinking of something back there. What were you thinking? I thought I saw your hand going up.
No, I would just, yeah, I was raising my hand.
Oh, you were? You sure? Okay.
Yeah.
I want to pick your brain if I can. That's okay. I'll let you go that way. Nick?
Does it depend on how you define confidence?
Totally it does. When you say you're 95% confident in something, since Austin brought this up, thank you, sir, what does that mean?
So you're pretty sure of it.
What does that mean, pretty sure?
Are you pretty sure that's gonna be close?
Pretty sure it's, what's close?
Like, what's the standard deviation of
You guys keep talking about standard deviation. I see no such standard deviation up here.
95% of the time that's gonna happen.
Who? 95, what's going to happen 95% of the time?
47%.
Oh, okay, we have a new definition of confidence. 95% of the time we're going to get 0.47 as a result back. I still think that's pretty ballsy. It's less ballsy than your first claim. The reason I think it's ballsy now is you're assuming that we just got the right answer most of the time. Now, it makes sense if it should happen 95% of the time that we landed in that 95 right now. I still think it's pretty ballsy. You think, Joe? What do you think? What do you think?
Is this where the plus or minus 0.05 comes in?
Okay, so now we're talking about this standard deviation idea. Hold that thought, Joel. Thank you for that. Yes, a plus or minus needs to show up here, right? Alan, go.
Basically the same thing I was gonna say. There needs to be some sort of movement in that number.
Yes. There's got to be some... So what we've just decided is, this is that center of the estimate. We need to put wings on that estimate to make it better, yes? See, here's what we're getting at, friends. And thank you, Austin. Thank you, everybody. There was one more set of hands. Veronica, what you got? Go.
So, would another way to approach it be to do this
Make me happy.
more times and then do that average?
Give me maybe till Tuesday on that. What the hell? Let's answer right now. Yes, if you can get better data, you always want to do it more times. But there's a reason for that you might not get right now, but you definitely want to replicate because you pick up precision. You learned that in 243.